Let's look at how we can calculate percentile ranks and areas under the normal curve using just raw data. We're going to assume that the raw data is normally distributed, and we'll be able to get basically a percentile ranking for each raw score that we have. Now, what does this mean? In Here we have our 5 girls that all have French names sitting around talking about what they eat, and they are at Taco King, and they notice that they go to Taco King fairly regularly, and they almost always eat the same number of chips. Brittany doesn't eat any chips. Lorraine has 3 chips. Rochelle has 8 chips. Brie has 11 chips, and Paris has 22 chips. They want to know how unusual their chip eating habits are. And so they said, "Oh, let's compute z-scores." That sounds like a good idea, except how are they going to do that? You need to know the mean and the standard deviation. Well, it turns out that there's been a waitress that's been working at Taco King for 37 years. And so they decide to ask her, how many people or how many chips do people usually eat? And the old lady who works there says that, oh, the average person eats about 8 chips, and almost everybody eats between 3 and 13. Well, not almost everybody, most people eat between 3 and 13. So that means the average is 8, and the mean is between 5, or the standard deviation is 5, which means that most everybody eats between one standard deviation below the mean, which is 3, and one standard deviation above the mean is 12. The majority of people, not most of the people. And that's a rough estimation of the standard deviation. So most people eat between 3 and 13 chips, so the standard deviation is 5. Well, the first thing we want to do is we want to calculate a z-score. So we're going to use our formula for z, equals x minus the mean divided by the standard deviation. And so here we're going to type in the second column for z-score. We're going to do equals, and then we're going to open parentheses, and E5 is our value. And what we want to do is we want to subtract the mean from that, which is E11, but we want to use dollar signs because it doesn't change position, close parentheses, divided by the standard deviation, which is E12, again with dollar signs, dollar, E, dollar, 12, and I can press enter, and that gives a z-score of minus 1.6, which makes sense. 1.6 of 5 is 8, so 8 minus 8 is 0. And then we're going to drag this down, and we get the z-score for everybody. So it ranges from a minus 1.6 z-score for Brittany to Paris, who has a 2.8 z-score above average. She eats a lot of chips. Now, what we want to do is, in order to understand their percentile rank, we want to understand what percentage is underneath the bell curve to the left of our z-score. So down here we have an illustration of a z distribution, and if we want to know the percentile rank of this z, we would need to know the area, this pink area, everything to the left of it. And we can get that into a fraction, and then we can convert that to a percentile. And the way that we do that is with this Excel command, equals norm s dist z. That's a normal standardized distribution of z. That gives us the area to the left of z. So I'm going to type in equals norm s, so it's normalized standard distribution of z, and our z-score is going to be F5, close parentheses, and turns out that that's 5%. Now I want to fill up the rest of the cells, so I'll overwrite all cells there. And now let's get rid of some decimals. So I'll go to home. So I highlighted the column, went to home, went to the number formatting, and changed it to number. And so that gives us a fraction to the left. And now let's convert that to percentile. We could multiply everything by 100. I'm going to say, I'm going to just copy that number equals G5. And I'm going to copy all that into the same cell there. And I'm going to highlight that, and I'm going to change this to, instead of having, I'm going to change that to a percentage. And so this gives the percentile ranking 5.48, 15.87, 50th percent. Paris is in the 99.74 percentile. So that's how we can create a percentile based on some raw scores. So we see Rochelle, she's right at average. Brittany is far below average. She's only in the 5th percentile. Cree is pretty far above average in the 72nd or 73rd percentile, but it's really Paris who's way out of there with her 22 chips. Now we might want to know what percentage of people eat more chips than the person that's in question. That would be the area to the right of Z. The way we can do that, to calculate the area to the right of Z, is we know that the total area of the normal distribution is 1. So if we say 1 minus this area, the pink area there, the norm S distribution of Z, that'll give us the area to the right of Z. So I am going to go to this cell, and I'm going to do equals 1 minus, and I will do G5, and I will get, so that's 95%, and I'll just copy all this, bring that down, and we'll get the different, the fraction to the right. Now I might need a few more decimal points to be able to see something so it's not all zeros there. And so that gives us to the fraction to the right of the distribution. So now we can, the area to the right of our z-score. So now we can start answering some questions based on these this data here. The first question is, what percentage of people eat as many or more chips than Brie? So that is a question where we want to look at who is to the right of Brie. And so that equals, we can say that equals fraction of people to the right of Brie. People that eat more would be to the right of Brie. People that would eat less would be to the left of Brie. And so we look on this table, and it is 0.274. So we can say that that equals 0.27, or we can say 27.4%. Now I'm putting a single quotation mark in front of this, so Excel doesn't interpret that as an equation. It knows that I'm entering text. So what percentage of people eat as many or more chips than Brie? 27.4%. Now, what percentage of people eat as many or more chips than Paris? Again, that's going to equal the fraction of people to the right of Paris, and that equals, in terms of decimal, that equals 0.003, which equals 0.3%, because we move the decimal point over 2% to get percentages. Now we want to answer the question, what percentage of people eat as fewer chips than Brittany? So that's going to be her percentile rank, and that's going to be the fraction of the fraction to the left, people that eat fewer chips than Brittany. That equals fraction of people to the left of Brittany. And that, whoops, I didn't put the single quotation mark in there. I'll put it in now. They're now recognized as a text. And that would be single quotation equals, and for Brittany, it's 5.48%, 5.48%. Okay. Rochelle is in what percentile of the chip eaters. She's right in the middle, so she's in the 50th percentile. So we can just look at that percentile rank there. Single quotation mark equals 50.00%. That's an easy one. And then pre is in what percentile of chip eaters? We can look there, 72.52% equals text equal quotation mark equals space 72.57%. And so there we have looked at how to calculate percentile ranks in areas underneath the normal curve from raw data and convert some of that information to percentiles.